Optimizers. This tool helps us visualize some common optimizers and their behavior in terms of how they converge to optimal solutions. Optimizers are a crucial component in training neural networks, including those used in AI, machine learning, and deep learning. The main goal of an optimizer is to minimize the error or loss function of the neural network during the training process. In essence, the optimizer determines how the neural network's parameters, weights, and biases should be adjusted in order to improve the model's performance. It does this by utilizing the gradient information computed during backpropagation to guide the updates in the right direction. Commonly used optimizers include stochastic gradient descent, SGD, momentum, and adaptive moment estimation, or ADAM. SGD, stochastic gradient descent, is a basic optimizer that updates model parameters by taking small steps in the direction of the negative gradient of the loss function. Momentum is an extension of SGD that introduces the concept of momentum, allowing the optimizer to build up velocity in directions where gradients consistently point. ADAM, adaptive moment estimation, combines ideas from both SGD and momentum while introducing adaptive learning rates for each parameter. This tool will help us visualize some common optimizers. Let's explore it. Please note that credit is provided to the tool's author and the Git repository. Here at the top, we have the 2D contour plot, and below we have a surface plot of a 3D function expressed as this equation. This function is basically a quadratic bowl with two minima. The two minima are at points 1, 0 and negative 1, 0. The size of these minima is controlled by the equation parameters a and b. We have used these parameters so that the output function has a global minima on the left and a local minima on the right. We will evaluate some optimizers to see how and where they converge. The best algorithms should converge to global minima faster. This 2D contour plot shows these global and local minima points here. So we have the global minima on the left and local minima here on the right. These are the optimizers that we will compare. They are SGD, stochastic gradient descent, momentum, which is SGD with momentum, RMSProp, root mean squared propagation, and ADAM, adaptive moment estimation. By default, they are all selected so that we can compare their behavior. An important factor in optimization is the choice of initial state. That's where the optimization starts from. With the same starting point, different algorithms may converge to different minima very differently. SGD and SGD with momentum may converge more frequently to the incorrect or local minima, the one here on the right, while RMSProp and ADAM will more frequently converge to the correct or global minima, the one here on the left. We expect to see that for this particular cost function, ADAM is one of the best optimizer algorithms because it converges to the global minimum from the most initial points, and it's faster. Now let's start with this upper left region. So I'll click here, and as we can see, all algorithms converge to the global minimum quite efficiently. If we start from the lower left region, we see similar behavior. Next, we try the starting point from the upper middle area. Notice that all algorithms converge to the global minimum, but some converge faster than others. Very similar behavior occurs if we start from the lower middle region. Now let's start from the top right region, but slightly towards the horizontal middle. Note that some algorithms have converged to the wrong or local minimum on the right, while the others have converged to the correct or global minimum on the left. In general, ADAM converges to the correct minimum more often than the others. Similar behavior occurs if we start from the lower right but slightly left. If we start from the far right, so upper far right, middle far right, and lower far right, we see that they all converge to the local minimum. This also shows the importance of the initialization strategy of the parameters in machine learning, which requires a separate discussion and is beyond the scope of this topic. Let's say we want to observe the behavior of only selected algorithms. We can do this by selecting or deselecting some individual algorithm buttons like this. So I'll deselect momentum and RMSProp, and that leaves SGD and atom still selected. Now we can run the convergence animation from different starting points. This covers how this tool can be used to visualize some common optimizers. Please feel free to try this tool by selecting your favorite algorithms and starting points.